Welcome to today's community conversation. My name is Sean Hurley. I'll be your community host. We're joined by Saul Amor, and we're going to be talking snakes on a Dynamo plane today. So next, please, Saul. Community conversations provide opportunities for engineers, artists, and makers to meet in a safe live virtual setting, to share expertise, get to know leaders in their field, and grow their community network. The sessions are always supported by the Autodesk community managers to help guide conversation, feed important insights back to the community and to Autodesk, and to support the participants in getting connected to the expertise you need. All right. Chris has put some nice links in there for you. Anyway, before we begin, the housekeeping part. The line is muted to reduce the background noise. We do invite you to turn on your camera if you feel comfortable with that. Kind of gives us that physical space feeling. If you have any questions, use the Zoom little hand thing or post into the chat and we'll get to you. This is a conversation, so if you have something to add or something to ask, Saul and Jacob have always been great at that. The session is being recorded and a link will be emailed to all registrants and uploaded to the community conversation site. Ooh, the fun part, safe harbor statement, the legal mumbo jumbo. Basically what this says is that any decisions made are based on the products as they are in the state that they are currently, not any forward-looking statements. So it's just real simple. In the current state of the product. All right. Again, I'm Sean Hurley. I'm the Autodesk Community Engagement Manager. I'm a geeky technologist based in Bend, Oregon. Welcome, everybody.
Cool. Hello, everyone. My name is Saul. For those of you who haven't seen before, how's it going? Just me today. No, Jacob. I am the product manager for Dynamo. I describe myself as a curious human being. I'm based in Boston, but originally from New Zealand. So pleasure to talk to you all today. Please do fire through the questions. They'll be fed back to me from Sean and Chris because I'm presenting and I don't get to see the chat window. But if you do want to chat live, that is totally cool. More than welcome to.
And I do want it on the record that I'm pretty sure that Jacob's not here because Snakes on a Plane is the title, and he might be scared of snakes. Just my thinking. Sure.
Keep that one on the D-lows. Cool. So welcome, everyone. This is the 18th session in our series of Dynamo Office Hours. And today we talk about snakes on a Dynamo plane, which is a little pun. If you hadn't guessed, we're talking about Python today. We're talking about it at a sort of higher, more strategic level, as opposed to in the weeds, about sort of more generic Python things across all platforms. So not necessarily specific to a host, such as Revit or Civil 3D, which we will get to in a later date when we start to do host-specific content. And that should be upcoming in the new year. So what are we going to do today specifically? So we have an agenda like usual, where we have a 20-minute presentation, give or take. This is on Python today, or snakes on a Dynamo plane. We have a live demonstration. So we're just going to walk through a piece of Python code and explain it. It's essentially already written, but we can explore what it does together here today. And please do put any questions you have in the chat at the moment that you wish to ask them. More than happy to stop and divert and talk about anything that you see on screen or any other questions you may have at any point in time. Like Sean said, this is a conversation as opposed to me just talking at the screen for half an hour. So please engage. I'd be more than happy to work with you guys. So Python. So what are we talking about today? So to talk about Python, we really need to talk about the landscape of things that sit within sort of the Dynamo world and how Python engages with that. So Dynamo is built upon the .NET framework, of which Python also has to interact because a lot of the other software that we deal with inside of the Dynamo world also is built upon .NET frameworks such as Revit and Civil 3D and a bunch of other cool things. And so what the .NET framework is a cross-platform open source developer platform. So you can think of the .NET framework similarly for, as Dynamo is to designers and engineers, the .NET framework is kind of the same thing for our developers, moving into building the Dynamo world that everybody loves here today. Oops, apologies. It has a bunch of different class libraries and utilities. It uses the Common Language Runtime, or CLR, that can then run and execute your code and does a bunch of really cool things. So on top of that, we also need to talk a little bit about host applications. So this is where you would want to actually execute your Python code. So this is things such as Revit, Civil 3D, or Format. We have a bunch of other hosts as well. You can also obviously execute Python inside of the sandbox environment natively. Then we have Dynamo itself, which is our visual programming interface maintained by Autodesk. And we have this is built, as I mentioned before, on the .NET framework and can execute Python. And then we have Python itself, which is an interpreted, dynamic, object-oriented programming language from the Python Software Foundation, which is fully open source as well, and has a bunch of awesome resources that exist out in the ecosystem. So now that we know a little bit about the pieces of the puzzle, just a taste, when is it appropriate to actually use Python? So first of all, to hit the go button or to use Python, you can ask yourself a series of different questions. So are there potentially no existing nodes inside of the Dynamo landscape that do what you want to do? So this may be talking to an API in Revit or Civil 3D. It may be using an awesome Python library or module that Dynamo doesn't express natively. So not all API interactions have a node or out-of-the-box package. Here we're referring to Revit, and you can fill in the blanks using Python if you understand how to write that and understand how to talk to the APIs. It's also really useful to start prototyping inside of Dynamo. You can prototype in Python a little bit easier than in zero-touch nodes. It's pretty quick. You can simply write your code, hit the run button, and get a result returning back inside of your graph pretty quickly. And because it's a runtime language, you don't need to pre-compile or hard type your code. So iteration really is faster here, which simply means you don't need to go and build your code base. It will execute on the fly. It also allows for operations in multiple environments if you write your Python code in a sort of ubiquitous way, which means the same Python code potentially could be working and executing in Dynamo, in PyRevit, or any other place that Python code will want to execute, providing you have the specific flavors of how Dynamo talks to the Python code, which we'll get to in a second, at the top and bottom ends of your code. And also it gives you access to a bunch of really awesome Python libraries through the Python, essentially the Python package manager. And we have current limitation inside of Dynamo to 2.7 libraries for IronPython. So apologies, this last bullet point is wrong. But we also have access to Python 3 or the Python 3 world with CPython, which will touch upon why there's a flavor difference in that later in this piece. So when is it not appropriate to use Python? So essentially, you don't really want to reinvent the wheel. So if there's already an out-of-the-box node, then I suggest you probably don't do this unless you want to do it for learning purposes. And with learning purposes, is totally valid in any way, shape, or form. Also, if there's another tool that exists out there where you want to potentially do something, but it's easier to simply download and use either a free or a cheap tool that somebody else has already built. And also when the benefits are outweighed by the benefits of another language. So a strongly typed compiled language has huge advantages over Python in some instances as well. So it's, again, use the right tool for the right job kind of moniker sitting here. And also when it doesn't make sense to automate. So when code, or why would you want to go to the effort of coding a task if there's simply a one-click solution that exists in the product today? If you want to chain a series of one-click solutions together, then Python could be your friend in that situation. So the Python node itself, we can actually access Python inside of Dynamo. And what is it? So Python is accessible in the library under sort of script, editor, or control flow editor, and then Python script or Python script from string, which are two different applications on how you can access the Python world. The Python script from string node is simply going to input text files and convert that to Python. And then the Python node itself, or Python script node, has a basic sort of Python editor, or IDE, as sometimes you might hear what it's called, which is an integrated developer environment. Essentially, the Python node is more of a glorified text editor, which has a few IDE features associated with it. And so the Python script node is way more common than the Python script from string node, and has a bunch of different little tools that we'll touch upon further in this piece that help you sort of execute your code and work with it a little bit easier than simply typing something from a string. So to access the text editor or IDE, you simply double click on the gray space of the node, and it'll pop open the window within which you can execute Python. And then the Python script from string node itself doesn't have an IDE and relies on code authored elsewhere. So it is inherently a little difficult to write Python code and simply in a string format inside of Dynamo. But if you have Python coming in from an exterior place and you like to use another editor to author your Python code, the Python script from string node could be your friend. So how does Dynamo talk to Python? So Python has an execution engine that Dynamo needs to talk to an interface with. So we need to transfer data from Dynamo to the Python node, essentially, before we transfer it or execute it and then transfer it back. So the Python node has essentially input ports and output ports. And you can have any number of input ports that you wish, and only one singular output port that exists on the node to date. And so the variables here are by default in0, in1, and 2 with a single output variable as well. But you can variable those inside of the Python code to make it a little bit more legible and easier for you to use as well. So you want to make sure that readability is key when you start authoring code inside of Python. So data can be sent into the node via these in variables. Any number or any type of Dynamo data that goes into there can be read within the Python world. We're talking strings, dictionaries, numbers, every single thing within the whole gamut of what Dynamo offers. And then from the output variable, you can only return a singular thing, or you can only use a singular output variable here to return stuff, but you can return multiple items within it, and essentially a list of items that come on the outset. You can return dictionaries back out to Dynamo as well, which is pretty cool. If for some reason you have multiple different out variables inside of your code, then the last output variable is going to be the one that actually returns values back into your graph. And what can be really useful potentially is to have a bunch of different variables that do this and simply comment out the ones to see what kind of results are coming through your Python code at any point in time. As a way to essentially preview the kind of content that you're building inside of Python. So now that we know how it talks to Dynamo and we know a little bit about what the outside of the node looks like, we're going to look a little bit at the Python editor features that exist within the node. So in essence, when you double click on that node itself, you'll see what is on the image and screen here and it is what is considered boilerplate code. So when you open this, this is the defaults that'll be here. We try to help you a little bit by having boilerplate code. That means you don't have to type this out every single time you want to access this. And so what the boilerplate code does is it imports a couple of different things, in this case, the SYS and the CLR modules. It adds a reference to proto geometry, which is the Dynamo geometry library, and imports that reference from the Autodesk.designscript.geometry libraries that gives you access essentially to every single piece of geometry inside of Python that you could have access to inside of the Dynamo world, there by default in this boilerplate code. There's a bunch of different commentary associated around this, and there's also the two different variables for in and out. You'll notice that the in variable here is just a singular in, and we can use the indexes of this in variable to get access to the granular data if we have multiple different input ports here. So in 0 would be the first index, and in 1, the second index, and so on. Then there's a bunch of different buttons, and this would look a little different compared to what you might see if you're in an older version of Dynamo to date. Previously, we essentially had run, save, and exit, and we, with the advent of Python 3 inside of Dynamo, have added a bit more content into this window. So on the left-hand side, we have run, which was there previously. We also have the ability to choose your engine. So if you want to execute IronPython code in Python 2, or you want to execute CPython 3 code in Python 3, that gives you access to doing that stuff. We also have the little 2 to 3 icon, which is a migration assistant. So that will take your code from the Python 2 world and migrate it up to the world of Python 3 as much as we possibly can. It doesn't capture everything, but it does enable you to have the bulk of your work done for you. And information around what the migration assistant is in the little question mark icon here, which will pop over in the sidebar panel and give you a bunch of information around how it works and what it does and why it might be useful to you. And then the standard save and revert buttons are as you would think they are. If you click revert, it's going to revert the code inside of the Python to the previous save state, and save is simply going to save that state. And then essentially, as we have with design script now, you also have line numbers in this. This helps you with the debugging of errors that may exist within your Python world. Cool. So I touched upon two different engines, and those engines were sort of IronPython 2 and CPython 3. So what are they? They're essentially two different flavors of Python. So IronPython is a flavor of the Python world, which has a particular integration that has its own runtime that executes in the .NET framework. What that means in layperson speak is any program that has been built in .NET, this is going to have a better time talking to it, and it's going to interface with all of the libraries and the modules that exist within that world. So it exposes some of the .NET expressions due to this runtime. It essentially works natively very well inside of this landscape. But the caveat here is it's currently locked into Python 2 world. They have released a beta version of IronPython 3, but that is still going through sort of an upgrade process, which means it's going to take a little bit of time before we could consume that. It's currently in alpha state, which means there's some good stuff in there, but it's not stable enough for us to put into product to date. And so for IronPython, we call inside of the Dynamo world IronPython 2 as a reference to the fact that it talks to the whole the world of Python 2 as opposed to Python 3. And so then we have CPython, which is a native flavor of Python itself. So this is using the Python runtime execution as opposed to an execution in the .NET framework. It uses another module called Python.net as a bridge between the two different worlds. So the .NET world within which Dynamo has been built and which Revit exists, and also the world of Python within which all of the Python modules and things exist. And it bridges between the two. So you can essentially use both worlds and propagate data between both. Python 3 is modern, it's secure and safe. So there's a lot more security that goes into Python 3 as it's under active development today, as opposed to IronPython 2, which is now essentially put into maintenance mode, and they're not really going to put any more updates when it comes to security. Hence why we have shifted to CPython 3 as our default moving forward, because it is inherently much more secure, much safer, and much more modern, as well as having a whole bunch of really cool things and new modules that you can play with and do cool stuff. So it gives you access to these really popular, high-powered and powerful Python 3 modules. So you want to do anything in sort of the machine learning world, there is a bunch of different really cool stuff. Or in the data science world, a bunch of really cool stuff that exists inside of Python 3. Correct. So that's kind of a set of framing things. And as we move through this, we're going through a bunch of different concepts. One of those concepts here is namespaces. So this is like the relationship of things to other things. So if you're obviously familiar with Dynamo, you'll understand that the library has a representation of this. So if you derive down into subcategories inside of the library, those are essentially these namespace relationships that exist within Dynamo. If you're in the geometry library, you have a namespace relationship between things such as curves and lines and arcs that allow you to sort of interact with those different pieces of the puzzle at different like hierarchical levels. So essentially what a namespace is an abstract container to collect logical groupings of unique names or identifiers. So the reference here is we have a namespace of fruit. Sort of pretty basic example. Inside of the fruit namespace, we can have any number of different fruit. We've got two represented on screen right here as in mango and pineapple. And so these are like the classes that exist within that. Then we have methods, so how you can create things or do things to something. In this case, we could propagate a pineapple plant if we wanted to and create more pineapple plants. And then we have properties that are associated with these as well. So in this case, we have like the pineapple fronds that exist within this plant. This is a way to start understanding sort of the relationship between different elements and understand the hierarchy that is associated with these. So anything that can play on the namespace of the fruit should also play in the namespace of everything that's derivative of that as well. So you can essentially think of this as a parent-child relationship, whereas the children are inherent aspects of the parent. All right, and I'm going through this and I noticed we haven't had any questions yet. So either this is awesome stuff and everybody's getting it, or it's flying over people's head. Hopefully maybe somewhere in the middle, and we can get some good questions coming through as well. So when we're talking about executing Python, Python is really serious about grammar. And Python deals with, or when you're writing Python, it deals with the legibility of code or how to read that code in a slightly different way to many other languages. So many other languages use brackets, as does DesignScript, and it enables you to sort of encapsulate different pieces of code at different levels, whereas Python essentially uses indentation instead of bracketing to define blocks of code. This is, at least for me and for many people, much more legible and easier to read, but it also means you have to deal with it and be careful about your indentation. So in other languages, indentation is a stylistic choice, whereas in Python, readability is prized and indentation is not a stylistic choice. It is something you have to do to execute your code correctly. So what this does is it gives you a natural level of clarity and legibility, which is awesome. And you have two different options within indentation is to either use tab or forced spaces. And in the CPython world, in the IronPython world, the old world of Python and Dynamo, you can use either. In the new world, we really recommend using the forced spaces, as this is the preferred approach. And if you have any kind of mixed indentation, which we'll touch on in a little bit, there's going to be a problem associated with that too. So if you can find the default, which is forced spaces, any content you find online and try to copy through into your code should execute much easier, given that that is the preferred option for most people who develop in the Python world compared to tabs. Tabs are a little easier, but they may cause issues downstream. So indentations of code essentially dictate to the Python world how this is going to execute. And so everything that is stepping in is going to execute first before anything that is sort of on the outset of that. So in the graphic here, we have a block of code or block of code 1. And block of code 1 is not going to finish executing until everything that's indented inside of it has finished executing. So the first thing in this graphic actually that's going to finish executing is the block of code number 3 here, which is the most furthest indentated. And once that's finished executing, block of code 2 can finish executing. And once those have fully finished executing, block of code 1 can continue and keep executing downstream.
Hey, Saul.
So, yes.
We have a question. Would you like me to read it to you, or do you have the chat up?
I put the chat up. Here we go. So, and forgive me if I butcher your name, Sevalod. So when I work the IDE and send code to the user, I run into the problem of unwrapping the code for development and wrapping the code back into the internal Dynamo console to send. This takes some time. It's not long, but it's the most boring time of my life. So I propose to create a small utility for Dynamo that will speed up the process of unwrapping code into IDE and vice versa. I'd be very grateful if someone would write it. Yes, essentially, we're not actually going to touch upon wrapping and unwrapping in this presentation today, because that's more specifically focused on the Revit integration and Civil 3D and other integrations. But yes, it's essentially, we have wrappers around the objects that come into the world of Dynamo. So if you're trying to use, say, a Revit family and pull some parameters and data from that family, Dynamo will give you access to a certain amount of stuff. And if you want to have access to the full API, you need to essentially unwrap that package. So it's a meaty concept that we'd probably have to tackle with a few slides and another presentation. But essentially, yes, it is time consuming, and it is a little esoteric with how to start thinking about, accessing the same thing in 2 completely different ways that give you a series of different approaches. I know that doesn't really answer your question. We don't have any intention right now to write this wrapper, but if you submit a wish list item, we can have that on the back burner and get around to it at some point in the future. Cool, awesome. So then readability is essentially prized, as per the grammar slide here. Readability is prized in Python. So they have their own style guide. It's called PIP8. If you're curious, go and check it out, and they'll recommend how to best write and execute sort of clear and legible Python code. All right, so this is not going to be super in depth. This is going to cover some of the basic object types, but these are the ones you're probably going to come into contact with most when it comes into the Python world. So there are other things like dictionaries and complex numbers and long numbers and things that we're not really going to touch today. But essentially, if you're looking to read Python code that somebody else has written, or you're looking to dabble in this world, then looking at these sort of 4 most common approaches to object types inside the Python world are going to be the bread and butter, so to speak, of what you're going to work with. So numbers, similar to Dynamo, come in 2 primary forms, integer and float. So int simply means whole number. So in this case, we have an example of 1, and a float is reference to double or just number inside of the Dynamo world, which is simply like a floating point or a decimally placed pointed number. So anything 1.5, 1.0, 1 point anything, and any other number with a decimal place inside of it. So these are referred to as a float inside of the Python world, and an integer is referred to as an int in the Python world. Then on top of that, we have strings, which are similar to in Dynamo and design script, but you're allowed to approach making strings inside of Python in 3 different ways. So you'll see either apostrophes, quotation marks, or triple quotation marks, and they give you access to essentially the same thing, but in slightly different ways. And the triple quotation marks actually enable you to do like wrapping around different layers much easier than the other 2 options. You will notice that the colors are slightly different for the 3 wrapped string option here, because you can actually also use triple quotation marks to essentially comment out a bunch of your different code too. So it's approached from a color perspective slightly differently. We then have lists, so they're very similar to in Dynamo, and they actually match design script now with square braces, and you can add anything comma separated inside of that list, and that will be returning a list back into Dynamo and using as a list inside of the world of Python. And then variables, similar to design script, which we touched upon in the previous session. You can simply name any of your content here, any variable name that you wish, and you can output that and use that as well in other lines of code in your Python world. So in this case, we're simply calling variable a list of different things, and that's everything above it essentially associated inside. And we can return that back to the world of Dynamo, and it's going to showcase the values that they come back as, so in this case, in 64 and double and string and null and so on. Now, one thing to note that a null inside of Python is called a none. So there's a little bit of difference, and there's a little bit of mapping that happens between the different object types that exist. For the most part, they're very similar. There's 1 or 2 that are a little different, and none is one of them. Annotation. So good practice, ensuring that you tell the correct story really comes down to annotation. Similarly to how you want to annotate your graph, you definitely want to annotate your code. Typically, decisions are made when you write something for valid reasons. It might not look to the outside eye like it's the right reason at the time, but it almost always is. And the way to record that is through annotation. So essentially, if you have boilerplate code as in the top value right here versus annotated boilerplate code, you can actually explain to not just somebody else who may read your code, but yourself in the future, what you were doing at that point in time and why you were using something. And that's really important for legibility reasons, for coming back and getting up to speed really quick reasons, but also for shareability things as well. So in order to annotate, you need to use either a hashtag, which is a single comment per line. This is either done on the line above or actually in the line of code itself afterwards. And the hashtag means that the Python execution engine is simply going to ignore anything that comes after that hashtag on that line. So you can write using numbers, you can write using apostrophes, any form of grammar whatsoever there, and everything after the hashtag is going to be ignored. And then you can also do multi-line comments using triple quotes, and that means anything inside of those triple quotes is essentially going to be ignored as well. This is slightly different to using the triple quotes as a string, which has to have a variable in front of it. So the comments do not execute when the code is ran, so you can put any number of comments inside of there. It's not going to change the performance of your code inside of Python, which is awesome. So the more comments, the better, until you get to a point where you're writing a story and nobody has the time to read it. So somewhere in between that is probably the sweet spot. They're also extremely useful for debugging. So this is again commenting out lines of code to figure out what is going wrong in your code when you're trying to solve a problem. And they really are a must for code to scale. So you really want to be able to use comments if you're going to do something that you want to have any degree of longevity. If you're simply just writing something for fun and trying to explore stuff, you don't necessarily need to comment it, but it is best practice and we would recommend you do that. All right, comparison to the membership. So another couple of building blocks in the Python world is comparisons and membership. So this is, is a thing or is a thing inside of another thing? And essentially, a lot of these building blocks that we're going to talk about today build higher level functions that do really cool stuff inside of the Python world. But understanding these sort of building blocks gets you a really long way inside of Python. So membership operators saying whether a thing is inside or not inside of another thing. And this is simply using the variables of either in or not in. And you'll notice that these will highlight themselves as pink inside of the Python world. They're reserved keywords, which means you can't use them in any other context. If you have them inside of your code written this way, unless they're inside of a string, they're going to do something specific. And what in is going to do is evaluate a list of things to see if what you're evaluating exists inside of that thing. So in this case, if we're looking at the code up here, we're checking if inside is inside of a list called membership list, which is simply a list of inside. A little bit sort of inception-y going on here, but essentially this is going to return true because the thing we're checking, if it exists inside of a list, is returning true because it does exist inside of that list. The inverse of that is not in, which is essentially the not variable is going to inverse the result of the in variable. So that would return false if we use not in here. And then we have Boolean operators to check if a list of values are either true or false. So and evaluates to true if all elements are true, and or evaluates to true if any element is true. So this is similar to what you might have used inside of Dynamo in the nodal landscape, but it's also really useful to check sort of containment. So whether or not one little esoteric thing exists within a big list. And if it does, then you can go and do a sort of more comprehensive, computationally heavy execution event on that. If it exists in there, and if it doesn't exist, you can say skip that container. We then also have comparison operators that allow us to check relationships between things. So this is stuff such as greater than equal to, not equals to, and so on. So not equals to is similar to not in, whereas it's simply inverting the equals to moniker here. That's comparisons and membership. And then we get into sort of the meat of really why most people invest in Python. So the two primary entry points into Python are either I need to use this because there is no existing node that exists to do what I want to do, or I want to build a series of different operations that are going to run through essentially loop, which is what we're talking about now, and loop many different operations or chain many different operations. They're going to run across a container or a bucket of things. So there's a heck of a lot of power that exists within loops, but there's a little bit of pain if you get it wrong, and it takes a little bit of learning to wrap your head around them. One of the things that Dynamo does do very, very well is it automatically loops nodes over data. So it takes this mental heavy lift away from you and allows you to simply work with the data. So if we're talking about list level, we're talking about lacing, Dynamo nodes will take the data and then figure out how the data should be applied to whatever function you're using. However, in Python, you have to manually specify how that data is looped over. So this takes a little bit of a sort of switch in thinking about how to start working with loops. So what loops do is they iterate over a container or a list and perform an action or a series of actions on those comments. So essentially, there's two different types of loops that we're talking about today. So there's the for loop and the while loop. And the for loop says for every single item in a container, perform a sequence of actions. So conceptually, you could think about this. Say you have a basket of apples. So you could say for every single apple in this basket, take out that apple and peel that apple. So in essence, you have a container of things. You want to take something out of that container and perform an action on it before you move on and do something else. So maybe the action sequence would be peel the apple, then place the apple into a baking tray. Whereas with a while loop, it says it's using conditionals. And so until a condition is met, perform a sequence of actions. So with the while loop application, you could say, I have a bucket full of a basket full of apples. And then while that basket contains apples, keep doing this stuff. So they're two slightly different entry points and they have slightly different applications as to how to use loops to aggregate over data. So one thing to be very, 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 very careful about is you can get into an infinite loop situation with the while loops very, very quickly, which means essentially Dynamo is going to be executing forever. And so you need to make sure you have an exit condition. So the exit condition can be numerous different things. In this case, the example on screen right now, we have a counter. So once that counter reaches a certain value, it's essentially going to exit that loop and allow us to finish or Dynamo to finish what it's doing. We can go back to doing something else inside of the Dynamo world. And an infinite loop might look like a freeze on your screen. It basically locks up Dynamo and you can't do anything else because Dynamo would be executing an event forever because there's no way to exit out of that loop. So a couple of really simple examples we have here on screen is we have a for loop, which simply takes in an input set of numbers and adds 2 extra numbers to them. So we have a series moving from 0 to 2 and 1 to 3 and 2 to 4. It's really simple. It says take every single number inside of this list and then just simply add to it and return it back out as a value. And then we have a while loop, which says we have a counter starting at 0. And while that counter is less than the number 5, we're going to append a message, in this case, Kia ora, Dynamo office hours, hello in Maori. And we're going to increment that counter up. So after we do it once, it's going to make the counter then 1, it's going to start again. And as soon as that counter becomes greater than 5, it's going to exit. So that's the exit condition for these loops. This is a big topic. And if you want to get into the world of Python, loops are really something you need to wrap your head around. They are conceptually a little esoteric, but once you start to get your head wrapped around how they work, you can actually find quite a lot of power within them. And there's some very simple examples that exist out there. These two on screen are not quite the most simple examples you could use because we're replacing values inside of the numbers list, but they're relatively simple. You should be able to figure out what's going on pretty quickly. So one way to start helping your experience inside of Dynamo or inside of Python is using the try except not states, what are they, like features essentially. And what this means is you can tell Python to try do something, and if something fails, then it's going to go and do something else. So in this case, it attempts a sequence of actions, and if they fail, then do something else. And in this case, we could also use this to send back that error message, which we'll talk about in the traceback module later on. What is really useful about this is you can use this in Python when you want to inform you what has gone wrong. For example, in your loop, so you could try to do something in a loop, and if for some reason it runs into an error message, you can simply execute. But do not overuse this because it can also obfuscate or hide problems in a code, because exceptions are exceptionally useful, and you want to see why they're coming through and fix them, resolve them, or safeguard against them to make sure that your code is more robust as time goes on. So in this case, what you'll see on screen is a little GIF, courtesy of Jacob. So shout out to Jacob on this one, where we have a string and a number input, and one of those is going to cause the first message to come through. So we're going to try to add numbers, and if that fails, it's going to come through and give the second message. So in this case, a little fun play on the world of Mario. And things can go wrong inside of the Python world, and this is what will propagate to your node if something goes wrong. So the whole Python script is going to turn yellow. It's going to give you a warning, and this is really what those exceptions are as well. So something has failed inside of the code. And what we need to do is we need to resolve that before the code can properly execute and therefore return a result back into our graph. And so we touched upon earlier this notion of tabs and this notion of spaces, excuse me. And in that, mixed indentation is something that is a huge no-no inside of the world of Python. And if you have mixed indentation, it's going to return this error message back to you, which is essentially saying inconsistent uses of tabs and spaces in indentation. If you ever see this error, turn on the feature, which is inside of our preferences panel now. It also exists in Python, sorry, in Dynamo 2.11 and 2.10, I believe, which is show white space in Python editor. And what this is going to do is show the non-characters as characters. In this case, periods will show, so spaces will show as periods, and tabs will show as chevrons. And if you ever see anything in an indentation set of code inside of Python, so for loops are a good example here, or if and else statements, if there's mixed indentation there, you need to essentially choose one indentation method. I would again recommend using the for spaces, even though I essentially cut my teeth on Python using tabs. I am making the effort to switch because it is more consistent with the rest of the world of Python.
Saul?
Yes.
Thomas had a nice suggestion. Would be nice to have an option to replace a tab with X spaces.
Yeah, awesome. So we actually do that. So if you're in the Python 3 engine and you hit tab, it is going to replace it with four spaces. So this is more of a case for the IronPython 2 implementation of Python inside of Dynamo. So automatically does that inside of the engine space, which is kind of fun. Cool. So with errors and debugging, like the first one's kind of easy. We've talked about mixed indentation. So now if you ever see mixed indentation, you should be able to figure that one out. But other errors may be a little bit more esoteric. So let's dig into this a little bit. So how do we actually resolve an error in a debugging state? So Dynamo's Python node is not a true IDE, like we said. It's more of a glorified text editor or an integrated text editor, and it actually uses Dynamo for its debugging purposes. So when something fails, it's not going to tell you inside of the Python editor. It's going to tell you on the node itself back in Dynamo, and it's going to propagate again node, and it's going to showcase a warning associated with this. So when you run your Python code, the error will surface on the node itself, not inside of the graph, and it will consist of a few different parts. So we're going to break that down a little bit now. So there's a few different parts that exist here in the graph are essentially the warning, and it gives you a type error. So in this case, it's an attribute error. You could also have type errors and a bunch of different error states, followed by a colon. Then it's going to give you the actual warning message itself, which is kind of the bulk of what you're going to look for. You don't necessarily need to care about attribute error versus object type error, although it does point you towards a better solution potentially if the error message or the warning message is esoteric. And then you're going to have a line number as well. So this is going to tell us where the problem exists inside of the code. So you can say, all right, so if it's at line 13, I need to look at line 13. And then it's going to tell me on line 13 what this warning message is. In this case, string object has no attribute join. So I can't join a string with a number without first converting that number to a string. So that's essentially what this warning message is trying to do. And warning messages are going to be as concise as humanly possible. So it's going to take a little bit of learning to get there first. You're going to have to essentially, just like learning Python is learning a new language and learning Dynamo is learning a new language, reading error messages takes a little bit of effort, but once you do wrap your head around it, they're extremely helpful, and they should be pointing you towards how to resolve whatever problem state you're in that point. So in essence, what you want to do is navigate in the reverse from how the error message is written. You want to first go to the line number, then read the warning message. And if that doesn't paint enough of a picture, you then want to go and understand what the type of error is itself. And that should help you navigate to a potential solution for that. So do we have anything in the chat? Sean. Thanks, Sean. All right, so if we're talking about Python, we want to talk about how you can extend Python, and this is around modules. So just like a package is in Dynamo, extends Dynamo and gives you access to more cool things, modules or libraries, as they're sometimes called, inside the world of Python does exactly the same thing. They're essentially a package for Python, and they enable you to have the right tool for the right job. And this simply means you do not need to reinvent the wheel. So if you want to fix a wobbly chair, what you're going to need to do is get out your toolbox, pull out a screwdriver, use the screwdriver to drive the screw into the leg, and voila, you've fixed your wobbly chair. If you want to draw a wall inside of Revit, you can go to the Revit API namespace, you can pull out the wall class, and you can use the create method to create a wall inside of the document. And so this is a module that would help you to do that stuff inside of the Revit world, instead of having to write things from scratch on the proviso that you could do something like that. It enables you to essentially get to the finish line faster and leverage all of the hard work, effort, wisdom, and knowledge of other people inside of the industry. So when you're importing modules, there's a few different ways that you can kind of do that, and you might have come across these if you've explored the world of Python. So there's many different ways to do things, and they have slightly different applications. Essentially, if you get it working, no way is really a bad way. You're not really going to impinge upon performance or any other issues too much. So if you get the result that you're looking for, it's generally pretty fine. But you'll see things such as like import X or from Y, import star, and a bunch of other different things, CLR or add reference. And what do they actually mean? So let's dig into that for a little bit. So import X simply means import that module. And so what that does is it creates a reference to that module inside of the Python world. So what it does is it loads a module into its own namespace. So you need to define completed module paths to actually access that stuff. For example, if we import sort of a module, it needs to be the module name dot whatever you're trying to do. So in this case, if we have a module called X, we need to say x.name or x.property and always have the X or that namespace associated at the front end. If we're using a from Y, import star or import something, import Z potentially, this imports the module Y and creates references to all public objects. So this loads it into the current namespace as opposed to creating its own namespace so that you can refer to it again without needing to mention the module name. So what this simply means is in the example above, you would simply remove the X. So you no longer need to clarify to say X first in the thing will just exist within the Python text editor itself. And then if you're looking at CLR.add reference, this is essentially for specifically for .NET assemblies, making the Python engine aware of them so they can then subsequently be imported as modules. So, we talked earlier a little bit about the boundary between the .NET world and the world of Python, and the boundary between Python and Dynamo. This is essentially making a bridge across between .NET and Python, and making sure that Python is aware of what exists over there so that you then can subsequently import those modules. All right. So if you want to import a module, how do you actually do it? So if you wanted to create your own module, and this is kind of like a simplistic example of what every other module would be in essence, you can create that module as a Python file that exists somewhere on your desktop or somewhere in your machine. The most simple one we have here is like a hello office hours or hello Dynamo office hours, which is a definition that is simply returning a message. And that message is just simply a string. So Python packages or toolboxes containing other classes can be loaded in from any external resource. And there's a package manager, essentially a Python package manager that has or houses a lot of them here too. So you can access that to find some really cool stuff. The packages would have to specifically be built for the version of Dynamo you're using. So in this case, if you're in IronPython, it has to be Python 2.7. And if you're in CPython 3, it has to be for Python 3. They are not going to work if they're not built for the correct version of Dynamo, Python. And you also want to add a location of wherever this Python file lives to your system path. So what this means is sorry, go ahead, Sean.
There was some relevant feedback there. When using output, this is from Anthony, when using outside module that requires installation using PIP, is there a way to get this module in other users' computer without having the user install it previously?
So right now, unfortunately not, but we have plans to ship the sort of 10 most popular packages or modules out of the box that would essentially enable the vast bulk of this to happen, like you're saying, Anthony. Right now, it's going to be on the next slide, essentially, or 2 slides from now. We're going to talk about how you can install modules inside of Python world, the Python world on your own machine. Unfortunately, that means the user has to have that module installed into their own Python world and their own machine, which we don't, from the Dynamo side, automate today, but we do have plans to make that experience smoother. And we had a couple of different approaches on how to do that, and we think the easiest one to do to start is to ship the most popular Python modules and have Dynamo understand them, which means unless you're doing something sort of really off left field, you should be able to ship that content to anybody else and have it work. Cool. So you can write your own Python files as much as you want, as long as you name this .py file and they have the correct kind of syntax associated with them, so they will not error out when you load them. All Python modules are written like this, but most of them are probably a little bit more complex than 2 lines of code. And modules, again, like we touched upon, are essentially packages for the world of Python. Cool. So kind of also tangential to your point, Anthony, what ships out of the box in IronPython is what they call the standard library of modules, which is essentially under your C drive, program files 86, IronPython 2.7, and lib, which stands for library. You get a bunch of different awesome modules that would probably cover 90 to 95% of the use cases you want to touch upon inside of the IronPython world. And so what this means is to access these modules, you just simply need to append the path of where they live. And so once you append the path to the system, which Python is essentially monitoring, you can then go and import anything from that path. So in this case, if we wanted to import, say, the CSV module, we'd simply import CSV underneath the sys.path.append in our line of code, and it would actually import that CSV module from the world of Python. So essentially, once we import that path or append that path, Python is aware of what exists there. And once it's aware of what exists in this library location, you can import any of them into your Python environment. So IronPython 2 libraries here do work in CPython 3 as well, for the most part. I haven't personally tested every single one, but every single one that I have tested does work. So there's some pretty cool modules that exist in here. And some of the ones you may want to start playing with and exploring is something like csv.py, which is working with sort of CSV and Excel files, random.py, which is like a randomization library, very similar to what the nodes do in Dynamo today, and os.py is operating system stuff. So if you want to get things like your machine name, your operating system, the amount of cores you have in your machine, all that kind of stuff to understand why someone's graph may be running slower than somebody else's graph and do that remotely from a central location, you can start leveraging some of these packages to do that by querying machine responses and then pushing that data to a CSV file somewhere centrally. So there's really cool stuff you can do with these modules, and I'd strongly suggest everybody check them out if you want to explore the world of Python. There's some very good stuff in there. It will require a little bit of Googling to understand what they do, because some of the names are a little bit esoteric here. So dis.py might not make sense to people, and there's a bunch of other just essentially random strings of numbers, of letters that do really cool things, but they're maybe a little bit harder to understand without Googling. All right, so Python 3 modules. So this is kind of to your point, Anthony, as well, around getting access to powerful and cool stuff. We have a guide, and so that guide is what you see on screen right now. It lives on our GitHub wiki. It's called Customizing Dynamos Python 3 Installation. And what that means is it takes you through the steps of going about exploring and getting these Python 3 modules, which essentially means you have to install Python on your machine. You have to modify some of the paths so that Dynamo understands where those modules live. And then you use the Python 3 install and pip, which is the Python package manager, to install those packages, and then Dynamo can refer back to them once they're installed on your machine. It takes a few steps. It probably should only take you 5 to 10 minutes if you're familiar with a little bit familiar with how this works, and not too much longer if you're not. But this then does give you access to download anything that you want to from the Python packages index and automatically sync those within Dynamo, in the world of Dynamo. So you can simply import those afterwards. So you'll notice in the Python script here, we're simply importing pandas and calling it an alias of PD here. We don't have to have a sys.path.append or make Dynamo refer to any of these locations, because it inherently does understand these locations. So this is the state of play today. What we want to do is have a bunch of these packages shipped by default, which means users should be able to just import them as well like this. And then in the future, look into a better way to be able to share content like this. And the narrative of Dynamo's work in the upcoming year is going to be working better with other people. So sharing and collaboration and content reuse, which a lot of your question falls under. Cool. And so Python 3 gives you access to the modern world of Python, which is secure and safe and does really awesome things, and the ability to leverage really powerful libraries. And these powerful libraries are things like NumPy, Pandas, Keras, or TensorFlow. People do really interesting data science operations on this using extremely large data sets. And what you see on screen right now is just a very simplistic exploration into Pandas data frame, where we're playing with some Marvel characters, their ages, and their sex. Pretty fun stuff. And now if we get into some useful Python modules, traceback I mentioned earlier. So this is essentially taking that warning that did propagate up to the node and now propagating it out of your output port. So if you wanted to log this somewhere, this is the way that you can go and log this error. So if we have a try except value, which we touched upon earlier, you can try to do something. And if it fails, that means the exception indentation is going to execute. So if you try something, in the event of a failure or an exception that propagates, then do something else. And in the advent of an exception, we're going to format the message that is returned back to us and simply push that back out into a way, or into Dynamo through the output port in a way that is legible. You can use that as a string to then push into, say, a Slack notification or an email or a central repository somewhere that somebody is monitoring. So it's super useful in the context of try and accept. Basic messages get passed back into the world of Dynamo, and it's a really useful way to start breaking up your code. Again, knowing that try and accept you should use sparingly, where it makes sense, not necessarily through absolutely everything you do in your code, because you do want to make sure that those errors are captured. And one way of capturing them is through this traceback method. So it's a really good way to log stuff, essentially. Another really interesting module is a module called inspect. So if you've used Python, you might be familiar with the dir or directory call inside of Python. This is another way to approach that. You have to import a module called inspect. And once you inspect this module, it gives you essentially more information on what exists within any given library or module. So in this case, we're inspecting the CSV module, and it's going to tell us, what are the methods associated with this? What are the members associated with this? What are the documentation associated with this, and so on. So it helps us get information around these modules. This is anything that exists within there, including modules and classes. And using the call of inspect.getMembers on a particular module will return the members, and it'll tell you how to write them in code as well. So if you look at the blue outline here, simply writing csv.dialect with the correct capitalization. So again, Python, like DesignScript and like everything else in the world of Dynamo, really cares about capitalization. I will give you access to that method inside of the world of Python. And then inspect.getMembers, and you can, again, derive down into things. So you can say, all right, csv.dialect, instead of using that method to create something, maybe you want to inspect it, and you get to a level where you can see the doc strings, which is essentially the help file that is associated with every single member. You can also access it in other ways by using like .__doc__, and a bunch of other different cool things. So that helps you better understand inside of Python how to work things, but I would suggest that the best way to learn about modules is still via Google, the internet, and the Python documentation is extensive in this world, which is cool. So there's many tutorials out there that will help you get to the result you're looking for. All right, so that's the bulk of the stuff we're covering today, bearing in mind that we're not covering specific things around Revit or specific things around Civil 3D, and they'll be touched upon in the future. So there's a bunch of different resources that can help you get to where you want to go. So the Python platform documentation is extremely verbose. There's lots of information there, and I recommend you go and explore this. Docs.python.org is essentially where it lives, and you can choose the flavor that you're using. IronPython is 2.7 as our flavor, and CPython is currently 3.8. So we'll be upgrading the CPython as upgrades come out from the world of Python, but IronPython is essentially static in time now. There's also the IronPython specific documentation, and also the ability to understand how to port code from Python 2 to Python 3 and what the differences are that exist there. There's also documentation for the Dynamo Api via fugit.org. And what this means is this automatically scrapes NuGets, and NuGets is essentially Microsoft's package manager. And the NuGets that we populate up there are things that we use to build Dynamo, and you can essentially go through and explore what the API is inside of Dynamo right now in this sort of automated form. This is not a real API website that we maintain. It's automatically made and scraped by somebody else, but it is useful. So you can go and check that out if you want to. In terms of other documentation, there's integrated documentation for a bunch of other places such as Revit and AutoCAD. There's the apidocs.co and revitapidocs.com. Revitapidocs.com has essentially been superseded by apidocs.co. So shout out to Guy Tallarico on that one. He makes awesome content that if you want to explore the API of Revit, Navisworks, or some other tools that he hosts, definitely go and check that out. There is also a bunch of different content inside of primers. So a shout out to Ollie Green for the Dynamo Python primer, which is a bunch of really awesome information. There is a repository that I started years ago that 10 or 12 different awesome people in the community have contributed to on GitHub, the Dynamo Python repository, which has code examples you can go and check out, which is awesome as well. There's a bunch of different sort of Autodesk developer network blogs that help. So the building coder, Jeremy Tamick, is a superstar in the world of the Revit API, if that's what you want to play with. Does some really cool stuff. And there's a bunch of other blogs as well coming through from different worlds. Then, of course, there's Autodesk University. So go and check out Autodesk University and play with some of the stuff that exists there. There's some interesting Python classes that still stand the test of time from 3 to 4 years ago. So go and check those out. Introductions into that world, so to speak. And there's a couple of highlights here that Jacob has put on screen as well. which is from Geek Tellerico session, which is awesome. I had a session in AU London as well around 2018, which goes through some more in-depth stuff from what we've covered today. Some more sort of in the weeds. So go check that out too. And then general resources that are useful. So Stack Overflow is a website where developers ask questions, similar to the way that everybody in the world of Dynamo uses the Dynamo forum today. So if you see Stack Overflow come up in your Google, definitely check it out. There's usually an awesome answer to questions that exist there. Of course, there's the forum. There's a bunch of really cool things inside of the forum that can help you. And then there's integration-specific forums as well if you want to explore the APIs of those specific hosts.
That is a lot.
And
then
then finally,
we're gonna have to
crazy amount of resources. Yeah.
Yeah, I got to share out. I'll share out a list of that for everybody.
Yeah, we'll definitely share out a list of all of these things. And then lastly, there's the Autodesk Developer Network as well, which is super cool. And if you want to get on board with that, it will help you sort of navigate this world a little better too. So live demo time. I don't know if there's any other questions in the chat before we go there.
It's just a comment from Thomas. I think the new print function to console was not mentioned yet for debugging, and the string IO module for older versions. But
yeah, good call. Yeah, good call and good catch. Unfortunately, there's so much stuff that goes into this world that I couldn't put everything in. But yes, you can print the console in Dynamo as well. So code that exists and uses print out there on the website. Well, sorry, on the world of the web, will allow you to essentially print the console and understand. So for debugging purposes, what is going on. So noting that the time is getting a little tight. We have about 3 minutes left. I just wanted to super quickly show something, and we can share this out for anyone who's curious as well. I'll stop share of this. I will share. Okay, oops. Looks like my PowerPoint, my Parallels is doing funky things. Let's try this. Okay, so essentially we were going to go through and talk through a Python script, which is going to execute on a surface. The surface is going to say, please, in a while loop, give me a bunch of different points on the surface and execute until we have maximum of 400 different points that have a distance spread of about 0.25 away from them. So in essence, if we go through the code here, it is heavily annotated, which is, and this is courtesy of Jacob, so shout out to Jacob on this one. This is going to take our surface and it's going to randomly propagate points on the surface and then propagate another point. And if it's within the tolerance, it's going to throw it away. And if it's outside of the tolerance, it's going to let it stay, essentially. So what we're doing through this code is we have a surface input, count, distance, and we have a population. And so while the population is underneath the total count value, we're going to attempt to do this 10 times maximum. So these are our 2 exit conditions. And then we're going to increment that attempt, and we're going to do a bunch of different random propagations using list comprehension. Oops, something interesting is going on in the back of my machine. And then we're going to essentially use surface.pointed parameter to put those on side of the surface. And then once they're on side of the surface, we're going to check if they intersect or if they're within this tolerance value and throw them away if they don't. So pruning the duplicates of these. Can push this out to anyone who wants, so we can put it on the thread side of the community conversations. I know we've got about 30 seconds left, so I'm going to stop sharing. We'll go back to the demo.
Yeah, there's a lot of feedback. Like, let's extend it 10 minutes. The only problem is some of the people in here may have hard stops, especially you, Saul.
I don't have a hard stop, but anyone who has to leave, apologies. This one was, I tried to keep it as tight as possible. It's unfortunately a little hard to keep it tight, but we have the share outs or the finish off slides here as well. This would be more sessions upcoming. So on November the 4th, we have the difference between Dynamo things. This is going to be around Dynamo custom nodes. So this is starting to explore that world. And then November 18th, we have how to make Dynamo sing, which is going to be about how to leverage what you can do as a user and make Dynamo faster, so more performant, both in a rendering and an execution perspective. And then on December 9th, we're going to have a wrap up, which is more going to be like a fun Q&A and chit chat. We can talk about what was fun for you this year coming to these sessions and what you might like to see in the specific host ones that we're going to plan for the year upcoming. So Sean, back to you.
All right. Well, thank you, Saul. That was awesome. And I know there's so much content. I wish we could just keep going. Maybe there's a time we can do that and focus deeper in those. But we're going to wrap up today with a couple final slides, looking for ways to connect with the Autodesk community. Chris just posted some links for us. Don't leave yet, though. We have a survey that helps us figure out the future of the program. of this pilot and how we shape it to better fulfill your needs. You can explore the many different ways the Autodesk community, including the global network of user groups, Autodesk Group Network, our industry-focused communities helping colleagues solve business challenges together with Autodesk forums, of course, and staying connected with us on Twitter. And there is the survey link. So if you could just take a minute, it's really quick. I think there's like 7 questions. But it's really easy ranking and just like what your feedback is on this program, how we can improve it. And it means a lot to us and how we shape and build out the program in the future. So your feedback is very important to us on your experience. Please stay connected with the Autodesk community, and we hope to see you next time.
Cool. And thank you everybody for joining today. I really appreciate your time and effort. Apologies, we ran up to the hour this one. It was a chunky one, so to speak. So lots more good stuff on Python to come with the host specific stuff in the upcoming year.
Yes, the Dynamo.
Dynamo Twitter. Yes.
Yep. Sorry, I was answering that one. You can answer that.
100% still active. I just need to be on it a little bit more. There's a few people that are active on that.